At the very foundation of electronics, there's only really two laws that govern your circuit solving techniques. The first one is Kirchhoff's voltage law, which states the sum of all the sources is the sum of all the drops in a loop of the circuit. Another common form you'll see is the sum of all the rises minus the sum of all the drops is zero, which comes in handy for certain solving problems. For instance, in this example here, we have two voltage sources and some resistor, and we're going to define the voltage drop across this resistor this way. And we know that for elements that consume power, if we define the voltage this way, that means current will be flowing through it like that, so that we dissipate power. So in contrast, the sources have the polarity defined plus and minus like this, which means current will be flowing through. Positive voltage, positive current means that we're producing power. So let's take a look at what KVL says for this circuit. If we use this form here, we can say that we're rising up by 4 volts, we're dropping by some voltage X, and then we're dropping again by a 1 volt source. And if we kind of picture that as a plot with different elevations here, we see we're starting off at ground in this loop, we're jumping up by 4 volts, then we're going down by Vx, whatever that is, and then again going down by 1 volt to reach back to the potential we were at the start of the loop. And if we just kind of write that down, that's 4 volts minus Vx minus 1 volt equals 0. Obviously Vx equals 3 volts. If we were to write this in terms of this, we would be writing 4 volts minus 1 volt equals Vx. And that's a little confusing for some people, so this, you can't go wrong with this way. The other law is Kirchhoff's current law, which says the sum of currents entering a node is the same as the sum of currents leaving. If we look here, we have 4 currents entering this node, which is this top wire here. The way we've defined our currents, we can say the 2 currents entering the node are IA and IB. 2 currents leaving the node are IC and ID. So obviously, by KCL, IA plus IB equals IC plus ID. And what's really cool is in electronics, when we deal with phasors and more complicated AC circuits, these laws still hold because assuming we have linear elements, these laws are still in effect.